Module 2. We're starting with Topic B, multi-digit decimal operations. So we'll be looking into adding, subtracting, and multiplying decimals. Today, Lesson 9, we're focusing on sums and differences of decimals. Topic 8 focused on fractions, and really fractions and decimals are the same thing. Fractions and decimals are both ways to represent a quantity less than a whole. So when we were looking at multiplying and dividing fractions, did we need common denominators? When was the only, usually no, we don't need common denominators for multiplying and dividing fractions. When was the only time we needed common denominators?
When you have to make a model?
Right, when we were making models. So when we're working with fractions, what are typically the rules? Since we're going into adding and subtracting, let's just refresh our memories. Common denominators, we need them for adding fractions, subtracting fractions, and when we're dividing, using models. Okay? Because today we're going to transition from fractions to decimals, so I just wanted to review that. We need common denominators when we're adding and subtracting fractions, and only when we're drawing models to divide fractions. If we're multiplying by the inverse, we don't need common denominators. Okay, I think we kind of beat that one. Okay, let's just move on. All right, let's review a little bit of vocabulary too. Since we're going to be talking about adding and subtracting today.
Is there extra help today?
We'll talk about that in a minute. All right, so adding and subtracting. When you're adding, the two numbers that you're adding together are called add-ins. Your answer is called your sum. For subtracting, your quantity that you have is called your minuend. The number that you're taking away is your subtrahend. And your answer is your difference. We're pretty much probably never ever going to say those words again, but that's just reviewing. Review a little bit of vocabulary. Let's also review our decimal place value. A couple weeks ago, when we were writing decimals, I think a lot of people got tripped up because they did not know their decimal place value. If you turn in your agenda, in the back, the reference section, page 3 has this place value chart. So if you need a review, it is there for you. Okay? So remember, fractions and decimals mean the same thing, just different ways to represent the same quantity. So everything red here is greater than 1. Everything in the blue means a quantity less than 1 whole. When we're reading numbers, what word do we use when we see the decimal? What word would we use? If we were reading this number, 23, everybody? Yes, and that's the only time in math we say the word and. It's one of my pet peeves, and now that we're coming up to New Year's, we're going to hear all those commercials. Oh, it's 2015. No, it's not. It's 2015. That's right. And the next time you get a wedding invitation, and they make it all fancy schmancy, they use a pretty cursive handwriting, and they write, oh, come join us, blah, 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 2015. No, it's not. Okay?
That is that one.
Excuse me?
That is that one.
Go home and check. I bet they wrote the year written out, 2015. But don't tell them, you'll embarrass the bride. It'll just be your little secret. But that's just how.
I swear.
But every wedding invitation ever, because that's just how they write it. And it happens. So and means you're about to start a number that's less than a whole. Now don't forget we have our tenths, hundredths. So here 500, since our 5 goes in our hundredths column, we have to put the 0 in the tenths column, because that's the difference between 50 cents and 5 cents. So you just have to be careful. So just a little review of your decimal place value. And if you need a review tonight when you're doing your homework, you could always refer to the chart in your agenda or print out these notes. Now, moving right along, since you have your conflict tonight, I know you'd like to start your homework. Let's get moving here. Okay, when we see a fraction, you know, sometimes when we're adding and subtracting fractions, it can become a little more complicated because when we're adding and subtracting, we need common denominators. So sometimes, instead of changing them to common denominators, it might be easier just to change our fraction to a decimal, since they mean the same thing. So today we're going to look at doing that, changing our fractions to decimals before adding and subtracting. So one more page of review before we jump right in. There are two ways to change your fractions to a decimal. The first way, we can take our fraction, if it's 1/5, take 1/5 and set it equal to another fraction with a denominator of 10, 100, 1,000. So 5 times 2 is 10, 1 times 2 is 2, so 2/10 equals 0.2. However, yes, it's called a magic one because we're not really multiplying it by 2. Because if we're multiplying it by 2, hang on, stay with me, I'm glad you pointed that out, because that's another pet peeve of mine. When people say, all right, let me finish. When we're making equivalent fractions, when we're setting equivalent fractions, people say, oh, take 1/5 and multiply it by 2. No, that means something different. When you're multiplying something by 2, you're doubling it. What we're really doing is multiplying it by 2 over 2. What does 2 over 2 equal? 1. And when we multiply by 1, are we changing the value? No, we're getting our same identity back. So 1/5 times 2 over 2. Or we're multiplying the numerator and denominator by 2. So be careful with your language. We're not multiplying 1/5 by 2. We're multiplying it by 2 over 2. So that we're changing how it looks, but we're not changing the value. We're not changing the quantity. Okay, what's your question?
What happens when you have where that goes into 10, 100,
Now suppose it's not 1/5, where our denominator would evenly go into 10, 100, 1,000, a million. Okay? Suppose it was 1/3. What's our surefire method that works no matter what our fraction is? No matter what our fraction is, what is our other method for changing a fraction to a decimal? In fact, what does that fraction bar mean? What operation does that fraction bar mean, everybody? So how can I read that as a division sentence? 3 divided by 4. So my other method, if it's a fraction like 1/3, 1/8, 1/9, 1/11, that cannot be equivalent to 10 or 100, could always divide the numerator by the denominator. So 3 divided by 4. This one works out nicely. It's called a terminating decimal because it ends. Terminator. Oh, you should not know what that means. It concerns me how many of you do that. All right, so that's called 3, 2. That's called a terminating decimal because it ends. If it was 1/3 and you divided 1 divided by 3, it would be a repeating decimal, 0.3333333, so we write it like that. If we were subtracting, we would just round it. So that would round to 0.3, 0.6666, repeating would be 0.67, but we're not going to see repeating decimals today, but I just wanted to throw that out there. All right, finally, jumping into today's lesson. We're going to follow 3 simple steps today. Step 1, we're going to convert our fractions to our decimals. Step 2, step 1, we're going to convert. Step 2, we're going to round or estimate to get an idea so we can figure out if we have a reasonable answer. And then step 3, we'll solve it. We'll do 2 practice problems, and then I'll help you set up your homework. and then you can get started on your homework. Sound like a deal?
Yeah.
All right, but you gotta stay with me. You have to work hard. Okay.
Never answered my question.
What was your question, babe? I'm sorry. Oh, we'll talk about it at the end of class when I'm done recording, okay? So, step one, because right now, can I add those? 25 and 3/10 plus 376 and 77. You're just a bundle of energy today. So can I add those?
You add the full numbers first.
Well, but first, before I do anything, can I add them like they are? When I'm adding fractions, I have to check that they have
Common
do
denominator.
they have common denominators? No. So this one isn't that difficult. I could change my 3/10
To 30.
to 30 hundredths, but we're going to convert these to decimals. So first thing, and this is what you should look like on your homework too. So we have 25 and 3/10.
Do we have to label the steps on the homework?
Well, I said I will set up your homework in a couple of minutes, but right now let's do some examples together first, okay? So you're going to start all the way to the left on your notes. Start all the way to the left on your notes. In fact, you know what? I'm going to delete all of this too. Ready? Watch. Here we go. Let's do this. Okay. Let's do this. Oh boy. Okay, so step one, we're going to write the equation. Now, let's rewrite those using decimals. All the way to the left, because we're going to spread across the whole paper. So this is,
Take a while.
gentlemen, I appreciate the participation and enthusiasm, but let's not cross over into disruptive, okay? Thank you. 376 and 77 hundredths. Who has a question on where the 0.3 came from, or where the 0.77 came from? Any questions on that?
Wouldn't it be changing to like convert it into 30 hundredths?
We're going to convert them to decimals today. You could, but I'm giving you the directions we're going to convert them to decimals, because I want to review fractions to decimals, okay?
Okay.
Now the second step, let's estimate it. So I don't know if you want to draw a dotted line to separate it, or, you know, it's okay. So the second step is to estimate it. 25.3, let's estimate it to the nearest whole number. We're not just going to drop the decimal, but we're kind of going to just drop the decimal. So 25.3 rounds to 25. And 376 and 77 hundredths. Be careful. Be careful. What is that going to estimate to?
375.
Well, we're going to round to our whole number.
Oh,
So
380.
The whole number. Well, if it was the tens column, that would be correct, but I don't want to go to the tens column. I want to go to the ones column. So 377. So let's add those together. Not enough folks to keep up with me today. So let's add those two. So we have an estimated answer. So 5 plus 7 is 2. So our answer should be about 402. Let me move my birthday cake. Then,
I know it's going to be.
oh boy, oh boy, oh boy. And then our third column, we will solve. So we are going to take,
Oh, we did this last year. I remember.
I'm
this.
sure you've done this many times. And did you give that teacher this kind of a headache too? Okay. We're not being boring. I don't want to be bored. Okay, so we take our original converted equation, and now let's add it. Now, what should we do here? We don't really need it, but some people like it lined up. I like it matchy-matchy. Oh, speaking of lined up, we forgot to review the numero in Porto, number 10. The rule for adding and subtracting decimals, we always have to line up the decimals. When we're adding and oh boy. Line up the decimals for adding and subtracting. 7, 0, carry the 1. 12. I did something wrong. Just carry. You're giving me a headache with all the calling out. Sorry. Okay, so 402. Is my sum close to my estimated answer?
Very close.
So, yes. Check. Yes. All right, step 1. So step 1, we are going to write our equation. 426 and 1/5 minus 275 and 1/2. Now we are going to rewrite them as decimals. 1/5 is one of those decimals that you should have memorized, one of those fraction decimal relationships that you should know. But if you don't know, you could come down to your margin and either set it equals, please let me finish, or divide. So if you don't have it memorized, there are 2 strategies that you can use to convert that fraction to a decimal. Find an equivalent fraction with a base of 10 or 100, or divide your numerator by your denominator. So what is it?
26.2.
All right, 0.2. What's 1/2 as a decimal? Okay, good. Now, our next step. Let's estimate. You want to draw a little, use your highlighter to draw a barrier for a column, you could do that. Title on top. So 426 to the nearest whole number. Yep. 275 and 5/10 to the nearest whole number. Good. Who is not sure where that 6 came from? 276. So now we can subtract. We have to do a little regrouping. All right, so our estimate should be about, our answer should be about 150. You want to use your highlighter? Draw another boundary. So when we solve, we're coming back here and getting our original. Now we can subtract. Go, do your subtraction. And what is the difference? What is the difference?
150.7.
150 and 7/10. Let's read it correctly, please. So now let's check our difference with our estimate, and are they close?
Yes.
Now, if they're not close, your mistake is not necessarily in your solving. Your mistake could have been in your estimating. But you should always go back and check both if they're not reasonably close. Okay, so yes, they are close. So now, in a moment, you can, in a minute, take out a sheet of loose leaf paper. In a minute, I said. I want to finish my directions, please, because you're making noise. Your homework, you're going to set up your 3 columns just like we did in class when you're starting your homework. Now the directions on the homework say you can use a calculator, but I don't think that that's necessary. I think one of them is 5/8 or 5/7, but if you use your division, then you would be able to solve, okay?